I've got this equation in rectangular coordinates. Now I know that's the graph of a circle centered at the origin of radius 2. So again, just from knowing that, I might be able to get an equation in polar coordinates. But notice x squared plus y squared is just r squared. So r squared is 4, r is plus or minus 2, and actually either of those would be sufficient. If my goal was to get an equation in polar coordinates that had the same graph, I could just go with r equals 2, which is the simpler option. I could also go with r equals negative 2. That's also fine. These have exactly the same graph. Now, if I'm working with this algebraically, obviously 2 and negative 2 are different numbers. But if I'm just trying to get an equation that has the same graph, this is probably the simplest one in that case. Okay. So make sure you're reading the directions carefully. If the directions just say convert this equation and express it in polar coordinates, this would be fine. If it says express this as r is a function of theta, then you've got to solve for r, so you'd have to get all the way to one of these two. This is solving for r, but it's giving you two options, and if you have two options, that's not a function. Functions give you a unique output value. So you'd have to pick one. So you just have to recognize that sometimes there's more going on, that you can have two different options that give you the same graph, but if you're asked to pick an option, just pick one. What I want to do, actually I want to have you do, is work with this one. X squared plus y minus 1 squared is equal to 1. Now I know that that's a circle, but its center would be at the point 0, 1 in rectangular coordinates. So it's not centered at the origin, so its equation isn't going to be quite as nice as just r is some number. Specifying the radius to be a fixed number is great if your center's at the origin, not going to work if the center isn't. So I do want to convert this to polar coordinates, okay? And it is possible in this case to find r as a function of theta. So r equals some expression in terms of theta that has the same graph as this. So I want you to pause the video. You're going to basically be doing what we did with the line. You're replacing x with r cosine theta and y with r sine theta, and then simplify it. Give me a polar equation that has the same graph, and I want it to have the form r equals some function of theta. Okay, make sure you justify all your steps. See you in a moment. Okay, so as I said, I'm just going to replace x with r cosine theta. So we're squaring that. Plus, then I'm going to replace y with r sine theta. But we're subtracting 1 from that before we square that, and then that equals 1. Now here, the exponent distributes over the multiplication, so that's r squared cosine squared theta, plus the exponent does not distribute over subtraction. This we're going to have to FOIL out. This is r sine theta minus 1 times r sine theta minus 1, and that equals 1. All right, so r squared cosine squared theta plus, let's FOIL this. We're going to have r squared sine squared theta minus 2 copies of r sine theta, and then plus 1 equals 1. Okay, from these first two terms, I'm going to go ahead and factor out that r squared, because I can see then that's multiplied by cosine squared theta plus sine squared theta. Then of course I still have my other terms, minus 2r sine theta plus 1 equals 1. Okay. But cosine squared plus sine squared is just 1. So I want to be on the lookout for things like that. If I see cosine squareds and sine squareds, if they're multiplied by the same thing and added together, I can factor out that thing they're multiplied by, and that simplifies this a lot. Now this is r squared minus 2r sine theta plus 1 equals 1. Let's go ahead and subtract that 1 over. So then I've got r squared minus 2r sine theta equals 0. Now I can factor a little bit more. I can factor an r out of here. And if I'd done that initially and factored an r out of all of these things, I could have done that, but I would have wanted to eventually factor out the other r here so that I can use that Pythagorean identity. Okay. All right, so now this becomes r times r minus 2 sine theta is equal to 0. So let's just take a look. Let me erase the top work here. Looks like once again we've got two options. R equals 0 or r minus 2 sine theta equals 0. R equals 0, that would be the origin. That's just a single point. If that point is on the graph of this equation, then it's not necessary to write that. If that's not on the graph of this equation, then I have to include both options. Okay. So let's see. This I could manipulate to be r equals 2 sine theta, just adding that over. That puts it in the form that I wanted. Is there a solution to this equation where r is 0? Yes, there is. I would have to pick a theta to go with it that would make the right-hand side 0. But as long as I pick theta to be a multiple of pi, that's going to make the right-hand side 0. R would be 0, so the origin is on the graph of this. So I'm just going to make a note. That's on the graph. So it's not necessary to state it separately. Okay. I do want to see some explanation that you get both options, but you only box this one if you were instructed to get your final answer in this form, which we were, okay? But you give me a reason for dropping that. You don't just ignore it because it doesn't fit. You ignore it because it's redundant to say that. This just says it's the origin. The origin is already on this graph. Okay? So all you need to do is point out that that's the origin and that it's on the graph of this function, and then you're good to go. All right, kind of neat. The graph of r equals 2 sine theta, it turns out, is a circle.